Okay, good morning to you guys. I hope you guys are doing well. Give me a like if you can hear me. It says on my end you can. So let's get those likes coming on in. All right, ladies and gentlemen. Let's go over here. All right, thank you guys so much. Let me do a few things here on my end. Okay. So we're going to go over to the browser, ladies and gentlemen. And as you guys know in the browser, we're going to document our internet speed. And we have to find it. So I guess we have to do it this way. I guess it wasn't there, but okay, well, let's find it now. We got it now. All right, let's try to do this here. And our download speed looks like it's going to be very good. And the upload speed is what you guys care about on my end. As long as we are at least 12 megabits per second, we are in good shape. So set YouTube to HD to maximize your experience. And ladies and gentlemen, okay, let's get on over to Math 241. So today what I'm going to do is this. I'm going to get back to the applications of law of sines and law of cosines. I'm a real big applications guy. So, you know, I feel why learn the trigonometry if you're not going to work on the applications? But what I'm going to do here for you guys is create a, you know, instead of reading questions, writing them down and, you know, drawing pictures for you, I want to do that ahead of time. So I want to get the pictures, I want to get the wording out ahead of time. And so I'm going to do that. That's my side project for you guys here. So I'm going to get that done, get that going for you guys. But we're going to move on today for trig identities. But we're going to get back to some of the applications so you guys know. Fun applications. We'll work with some examples. So make sure you work on law of sines, law of cosines, become an expert on that because it's coming in the form of applications. And, you know, that's what's going on. So today, I want you guys to download this trig sheet here, however, and I will put that in the comment section. And that's what we're going to look at today. We're going to look at this formula sheet and we're going to start working with identities. Okay? Formula sheet working with identities, ladies and gentlemen. So here we go. Alrighty. Formula sheet working with identities. So you head on to the iPad. Yeah. Just checking a few things. All right, never mind. Here we go. Okay. So working with identities, here's something I want to kind of say to people. First of all, if we do look at that browser really quick, I'm going to take an identity. Pythagorean identities. Here's a first identity. Sine squared theta plus cosine squared theta equals 1. Okay, so this is an identity. This is an example of our first identity. Okay, it's called a Pythagorean identity. And if you look at this and you say, well, you know what? That looks like a formula to me. And I'm going to put a question mark here on the iPad. Formula. It's not a formula. It's an identity. And then you might say to me, well, okay, this is an identity. What's the difference, right? Why is this an identity, and why don't we call it just a formula? Because formulas, for example, maybe I can say to you a nice formula like an equation, 2x plus 3 equals, 4. This only has one solution. In other words, there's only one x value that can work when you plug it back in. And you say, well, what is that x value? Well, if we solve this, 2x is 1, that x value is 1/2. So there's only one answer that will work. An identity, ladies and gentlemen, so if I go back, comparing a formula like we have here, this is only one value where you get a true statement. Only one value. An identity now, this works for essentially all real numbers. In other words, theta, which could be an angle which gets converted to a degree, which is a real number, it works for any real number, any value. So any number I plug in here in this particular identity will give you a true statement. So this is the difference between what we call an identity and really just a formula. Formulas work for one or two values. Identities work for all real numbers. So I can plug in anything there for theta, and it's going to be true. It'll satisfy that particular equation here. So, identities are really useful and powerful. They're equivalent statements. And so, we're going to have to start working with some of these identities here. For example, you might say, where does the statement of tangent here? If I look at this sheet here, tangent is sine over cosine. And we start to work with some of these identities. And you say, well, tangent being sine over cosine, where does that come from? I'm going to say this to you guys. Take a look. This is a left-hand side. So you have what we call a left-hand side and a right-hand side. This is my equal sign. So if you have a left-hand side there in blue, and then it's going to be equal to the right-hand side in gold. Okay, this is an identity. But identities, even identities came from somewhere. They just didn't fall out of the sky. So when people say to you that tangent is sine over cosine, there's a reason. There's a valid reason. And let me go through this concept with you of a proof. So if you say to people, can you prove this particular identity, this relationship, that tangent is actually sine over cosine? And the answer is yes, we can prove it. And let me show you how and what I mean by prove. This is where you start here. So I have a left-hand side. So I want you guys to start here by just sort of notating, okay, we're going to start with that left-hand side. The left-hand side is tangent theta. So the idea now behind demonstrating where this identity comes from, this idea about saying, hey, how can you prove this identity is valid? Well, you start with the left-hand side, at least for now. So you go, okay, what is the left-hand side? It's the statement tangent theta. What you're going to try to do is show that the left-hand side is the same as the right-hand side. So this is your game plan, because they're saying here to prove that these things are equal. So we want to show the left-hand side is equal to the right-hand side. Okay? And this is the game plan behind the concept of proving and working with these identities. It's a pretty big deal. Everything that we do in trig is used and is useful. Everything. And you see it in other classes later on. So I'm glad you guys have signed up for a trig course, because it means you're a serious student who cares about learning, and it means you're headed into a good direction like STEM. And I'm going to say this to you guys, like I'm going to tell you things like I would tell my own children. You know, people I love, people in my family. Work and major in STEM. If you want to eat, go into a STEM career, and you're going to earn it. You're going to need to learn, and it's a beautiful thing. You're going to have some knowledge, and it's meaningful. Knowledge is meaningful. So I'm going to say, hey, start to work with everything. And I know you guys have been doing that. So you've been doing it anyway. So start to work with this stuff in trig. Everything that we do is useful. I don't waste my time in meaningless stuff. So I'm going to say, yeah, these identities are really useful. So let's kind of take a look at what's behind the scenes here, right? We know tangent, ladies and gentlemen, is defined a certain way. Tangent is defined as y over x, where x is not equal to 0. And we have to go back to that unit circle. Okay? So we have to go back to the unit circle. So we remember this knowledge is the definition for those circular functions. And this is, you know, what it was. This is by definition from circular functions. Okay. But you also know that y was defined to be sine with those same circular functions. And x was assigned to be cosine. And it's from the same idea from circular functions. Okay? And so, ladies and gentlemen, if you said, Mr. Judge, that happens to be what the right-hand side is, and I'll say, yes, it is. That is the right-hand side. So you have shown that the left-hand side, take a look, all the way through, is equal to that right-hand side. So now what that means here is you have an identity under your belt, that tangent theta is sine theta over cosine theta. This is something that's known for you, ladies and gentlemen. This is something that you say, this is fact now. This is valid, because you actually proved it, and every step of the way, it's airtight. We just use the definition from circular functions. This is the circular function. You know, if you guys go back to that worksheet and the work that we did, this comes from circular functions. But this is an important identity to know. And if you look at the browser, you say, well, is that why they start off with tangent theta up there? If I even try to get it bigger, let's see if I can get and sneak in there, you know. The upper left corner, that's the very first identity they gave you. So, ladies and gentlemen, you know where it comes from. It just came from the definition of from circular functions. Now, that's an important thing to know. A lot of things come from definitions. So it's important to know definitions when you do things. Definitions are your life in some ways in a course, in a math course, and a science course. Definitions. Pretty much any course, you know, working with definitions. And this is airtight and it's solid. You show that the left-hand side equals the right-hand side. And I'm going to say, by the way, we have another valid identity for cotangent. It's the reciprocal. And it's proved the same way. Cosine over sine is proved the exact same way. And I'm going to say, you guys can do that. Try this out yourself. It's the same format here. Working with these identities. So, ladies and gentlemen, that's a pretty good deal. Now, I'm going to go to some more identities. I want you to note that you do have the reciprocal identities. we have something called reciprocal identities. Like, for example, cosecant theta is 1 over sine theta. Okay, we have all the reciprocal identities. Now, they call it an identity, but we gave it to you first as a definition. And what we gave really as a definition here, this was the definition. Okay, I gave you guys a definition by that sine theta is equal to cosecant theta, 1 over cosecant theta. It's the reciprocal. Okay, so this is what I gave you guys. But if they said to you, hey, let me prove this to you, believe it or not, this is the difference between me and your cousin that helps you in your homework, is Mr. Judge has experience in this great word known as proof, since in mathematics, that's pretty much what we do. And I'm going to share with you guys again, right? That left-hand side equals the right-hand side. Now, there's no law, even though I say to you, start with the left-hand side. Generally speaking, yes. In a proof, you want to start with the left-hand side, and you want to show it equals the right-hand side, okay? But you don't have to. I can switch these sides. I can even start with the right-hand side. And I can say the right-hand side is 1 over sine theta. So you can start with the right-hand side. And then in this case, now our game plan is to show the right-hand side equals the left-hand side. And I'm going to be a little bit, start with the right-hand side. If I can find, yeah, there we go. Okay, it's interesting. I never seen that before. So since my right-hand side is 1 over sine theta, here's what I'm going to use. I'm going to use the definition. Remember, we gave you the definition that sine theta, I get to do the following. Replace sine theta with 1 over cosecant theta. And this is by definition. Okay, so I gave you guys that definition. Right? This is by definition. And to remind you guys, the definition I'm talking about is sine is 1 over cosecant. And at this point, we say 1 divided by 1 over cosecant. This is 1 divided by 1 over cosecant. So I can use algebra and arithmetic along the way with my identities. And that's 1 over cosecant theta over 1, because you multiply by the reciprocal. And then 1 times anything is itself. So my point is that I just showed that the right-hand side, which is equal to 1 over sine theta, is exactly the same as cosecant theta. I showed that the right-hand side equaled the left-hand side. And there you go. And this is how we can show, ladies and gentlemen, the left-hand side is the right-hand side, or the opposite, the right-hand side is the left-hand side. So it doesn't really matter, because equality means, is the same as, right? This word equal, so you guys know, I want you guys to really understand this idea. Equal means the same as. In words, if I said to you, Jennifer Lopez is J-Lo. Okay? Is. That word is same as equal. I can also say J-Lo is Jennifer Lopez. These are considered the same exact statement. So this is what I'm referring to when I say to you guys, I can say the left-hand side is the right-hand side and vice versa. This is what's known as a reflective property in logic here. So this is why we can say over here, oh, I have on the left-hand side and it's equal to what's on the right-hand side. And then I just switch the sides. We could do that in proofs, and that's fine. We could start with a different side. So let's kind of note what's going on. Not only can I switch sides, left and right side, I can use past definitions, and I can also use arithmetic and logic here. So this is what's done in proofs. So let's note. In this world of proof, we use definitions, arithmetic, logic. And I'm even going to use the word algebra here. So I want you guys to write this down because this is pretty much the key here for working with these proofs in this chapter, starting this chapter. And we showed that cosecant theta is 1 over sine theta. And if I go over to the browser, notice that's the first reciprocal identity, and there's actually 6 of them, and they're all done the same way. All done the same way. Okay. Also, ladies and gentlemen, some of these identities you definitely have to know. Like if I say to you, Pythagorean theorem, right, or the Pythagorean identity, sine squared theta plus cosine squared theta is 1. Okay? Sine squared theta plus cosine squared theta is 1. Now, you might say, where does this come from? Well, we could do something like this. I can say, notice this is the left-hand side and it equals the right-hand side. So if I have to prove this, they have the word prove. I want you to know where this comes from, some of these identities. Prove that sine squared theta plus cosine squared theta is 1. So let me show you how a way that it can be done. Right, the left-hand side equals sine squared theta plus cosine squared theta. Okay? Because that side is on my left. And that's a more complicated side. So notice this. That side is more complicated. And now I'm going to say, go back to consider this world of circular functions. See, this is what you've known only from your past, circular functions, ladies and gentlemen. Right? And maybe if I said, go back to the browser, and if you go to the worksheets, and circular functions, something about, I think this is the first one. Let's double check. This is what I'm talking about. This was the circular function worksheet from the beginning. So if you said, what are you talking about, circular functions? I don't remember. Here you guys go. Here's your circular functions. There it is. This is from the worksheet unit circle. X squared plus y squared is 1, circular functions. So, okay. Here's what we have now. From the world of circular functions, what we can do is this. We can replace, substitute. So you might want to even start to consider the fact that we're going to have to do something also known as replace and substitute. You go, what do you mean replace? Substitution, this idea of substitution. Anybody know what that means? To substitute? And to replace? What we know from that circular function on this unit circle, right? This is a unit circle. X squared plus y squared is 1. What we know is that sine theta, the definition, is y. And we know that cosine theta, by definition, is x, ladies and gentlemen. Sine theta is y, and cosine theta is x. It's at the bottom. Tangent theta we already used is y over x, where x is not 0. We used that already. All right. So when I say to substitute, this is another big thing that we do in proof. If sine theta is y and cosine theta is x, I can now substitute right in here. This will be the y variable, and this will be the x variable. So wherever I see a sine, I can substitute y. Wherever I see a cosine, I can substitute x. Now, I want to remind you guys that sine squared is sine to the second power. Cosine squared is cosine to the second power. Okay, so if we can substitute, we can replace sine with the letter y, ladies and gentlemen. I'm going to replace it with y. We can replace cosine with the letter x. And so what you now see here is this nice relationship that we have y squared plus x squared. Okay? Because in proofs, yes, we need to replace, we need to substitute, we're allowed to do those things. So we get y squared plus x squared. Now, the order in which I add does not matter. So I can say this is x squared plus y squared. I can switch my order. And then now remember one extremely important detail, because we're on our way. If we go back to the browser, you can say, this is from the unit circle. And in the upper right corner, does anybody want to tell me, what do you guys see in that upper right corner? Let's see if you're awake. See if you guys are here and you're awake. Are you awake? Are you here? What does x squared plus y squared equal? This is from the unit circle. This is where it comes from. This is the setting. What does x squared plus y squared equal? Thank you, Viviana. I'm glad you're awake here. I'm glad you're with us, and I'm glad you're awake. Outstanding. And what that means is that this sum is equal to 1. Thank you, Mike. Thank you, Tiffany. Thank you, Claudia. Thank you, Paula. Outstanding. Good for you guys. Love that you guys are here. I wish I could take you in all my classes. Wish I could take you guys in all my classes, because that's outstanding here. Okay? So this is x squared plus y squared is 1. And then that's going to be your right-hand side. So ladies and gentlemen, what I have just proved for you guys, this is a proof of this very, very famous identity. The Pythagorean identity, it's known as the Pythagorean identity, is sine squared theta plus cosine squared theta is 1. Now, there's different ways to prove it, but this is one way. And this is kind of just getting our life started in the world of proof, ladies and gentlemen. And it's not too bad. It's not too bad. Okay? Don't look at this and say, this is the chapter I skipped. No, you don't want to skip anything in Trig. Trig is fantastic. It's a foundational course. The sad thing about it is that it's overlooked and it's brushed aside. And people look at it and go, oh, Trig is easy, and so you don't even have to, you could read it and stuff. I don't know about that. I think you have to take a course in it. You know, you do have to take a course in it. And without some fundamentals, like from geometry and some logic, like the idea of replacing and substituting sine theta is y, cosine theta is x, that's a big deal. You know, so I'm using all the kind of tools that you guys use, and I'm going to write them down here. We can replace and substitute. You know, that's big. All the tools that we use definitions, arithmetic, and algebra, logic, replace and substitute, right? I'll put that in purple. And this is kind of the idea. This is the foundation behind all this world of proof. Now, I want you to know something here. And I'm going to prove these as well. Let's go back to the browser here. That this isn't the only this is not the only Pythagorean identity. So if I go back to, oh, my worksheet is still, no, it's not there. So, all right, let's get rid of you. And I guess I'm here. It's called the trig. We're looking at this cheat sheet, right? If you look at the Pythagorean identities, it's not the only identity that we have. In other words, we have tangent squared theta plus 1 equals secant squared theta. Okay, it's in the upper right corner. There's another Pythagorean identity, and there's a couple of ways of showing this. I'll start again with the left-hand side equals my right-hand side. So to prove this, we can start to say, okay, we want to prove that your left-hand side, we're going to start with the more complicated side. That's tangent squared theta plus 1. Okay, so I'm starting with the more complicated side. And it happens to be on the left. No big deal. So tangent squared theta plus 1, that's what we're going to start with. This is a way we can show. And remember, you say, well, what do I have to show, Mr. Judge? We have to show that the left-hand side equals the right-hand side. And what's on the right-hand side is secant squared theta. That's on the right-hand side. That's what we have to show. The left-hand side is the same as the right-hand side. Okay. Now remember what tangent theta is. Tangent squared theta. Tangent squared theta, I guess we can skip spaces here, right? Maybe it's easier to see. Tangent squared theta, ladies and gentlemen, now I'm going to focus on this, is really tangent theta to the second power. Circular functions, y over x to the second power. And don't forget, this is plus 1. And so doing some properties, this is what I mean algebra. We can use some algebra. Okay, so I use algebra. You say, what property did I use? Well, I mean, this is essentially the property. Y over x to the second power, we distribute that power too. This is y squared over x squared. This is when I say, hey, we can use some algebra, ladies and gentlemen. You know, and that's why algebra is on the list here. So I put that word algebra. So we know we can use all these things in our proofs. Start with a complicated side, tangent squared, plus 1. There we go. I'm sorry. There we go. Here's where we're at. I just used some algebra. And I'm going to use some more algebra. And you guys want to get used to this kind of algebra. You're taking a fraction and you're adding it with a whole number. You can only do the following here. Algebraically speaking, we can only add fractions with the same denominator. So the algebra that I want to do now is I need the denominator of x squared on the right-hand side. So I need it over here, so I'm going to put it over here because I need that to add these terms. There's an x squared down there, but if I put an x squared there, I have to put an x squared on top because x squared over x squared, anything divided by itself is 1. So there's some more algebra here. And that's an important detail. So we get y squared over x squared plus x squared over x squared. We can now add. So you say, oh, y squared plus x squared over x squared. And I know what this is. I can now say x squared plus y squared over x squared. This is 1 over x squared. So I just showed that the left-hand side is the same as what you see here, 1 over x squared, using circular functions and algebra. Now, okay, What does this mean now? Well, where does this x come from? X comes from our circular functions. Remember, x is the value of cosine theta. So I can replace this x now with cosine of theta, and I square this. That gives me 1 over cosine squared theta. Okay, so this is 1 over cosine squared theta. And at this point, you might say, I don't know what that is. Well, 1 squared, believe it or not, this is the same as 1 over cosine theta to the second power. So I can replace this x with cosine theta because that's what it's equal to. This is a replacement or a substitute situation. Right? We can replace that. And so cosine theta to the second power, by definition, is 1 over cosine squared theta. This point here, this is some more algebra. Okay, so it's like the following. If I said to you, I have a squared over b squared. Can be thought of as a over b to the second power. This is another property of exponents. And then you have to know, what is 1 over cosine theta? 1 over cosine theta, by definition, ladies and gentlemen, was secant theta. And that's to the second power. So this is by definition of 1 over cosine theta, which tells you that this will be secant squared theta. Okay? And so this is the right-hand side. There's some algebra. But we just showed that the left-hand side equals the right-hand side, and that now means we are done. This is equal to that right-hand side. So you're done with this proof. So here's a standard way of looking at this Pythagorean identity here. Here's another Pythagorean identity, and the last one you see, the Pythagorean identity, is 1 plus cotangent squared theta equals cosecant squared theta. So I'm going to kind of do something here for you guys and take a look at this. 1 plus cotangent squared theta is equal to cosecant squared theta. And then look at these identities here. Here's what we're going to try to get to. You know, identities, everything that you see here, you say, well, these are all formulas. Well, no, they're identities, meaning they work for any value of theta. It'll be true and valid. But there's a lot of other identities you have to know. So what I'm going to say, look at the identities on the upper left corner there. Those are facts. They're all valid. So if I said to you, you know what? The previous proof, the previous Pythagorean identity, you can see this done a different way. Tangent squared theta plus 1 is secant squared theta. Let me show you another way to do that because it's going to be important here too. This could be done another way. You can still say, oh, left-hand side, right-hand side. Start with the left-hand side, the more complicated side, tangent squared theta plus 1. So this is where you're going to start. Okay? So you're still doing it exactly the same way. However, the idea also here is that we can use any other identity. So if I go back to that note here, we can also use, I'm going to move this all here. We know we can use all these tools, definitions. This is what we can use in working with identities. You could also use other identities. So I'm giving you guys some ideas here when you work with this. This is how you do this. And it's really designed to make your life easier. And I'm going to show you what I mean by that. I mean, everything we did here on the right side is algebra, and it's good algebra. We see this algebra all the time. But this is what I mean by using other identities. And you say, what other identities? The identities that are on this sheet. Okay? The identities that I just gave you guys. We can use those identities too. And I suggest you do that. So here you go. You say, what do they mean? Well, we already know tangent squared theta is the same as simply just saying, because you do have to know what this is. That power 2, that means that's the second power. You're used to seeing that power here. You're used to, if they put a 2 there, that's really on the outside. Okay, so you're used to seeing that. Now, this is what I mean by using other identities. You can replace, listen to the word I just said. We can replace tangent theta. Replace tangent theta with what? Does anybody see anything interesting about tangent theta? If you were paying attention and when you woke up this morning, tangent theta is the same as, what is tangent theta equivalent to? It's in your identity sheet. We can use other identities. What is tangent theta equivalent to? What do you guys think? Outstanding, Viviana. This is what I'm saying. You can replace tangent theta with sine theta over cosine theta. Yes. Thank you so much. Yes, you can replace tangent theta with sine theta over cosine theta. Thank you, Eric. Outstanding. Good job. Good for you guys. And that'll now be to the second power. So I did that replacement substitution. That's really going to be a key thing with working with these identities is substituting. And so now you might say, okay, that gives me again by algebra sine squared theta over cosine squared theta plus 1. And again, you say, what does that give me? Well, you're adding a whole number with a fractional component. This number 1, you want to remember what you do with this. I'm sorry, I'm looking for the right color. I'm going to replace the number 1 with cosine squared theta over cosine squared theta. Okay? Because anything divided by itself is 1. So I'm replacing again cosine squared theta plus. Now, why do you do that? Because now I can add, ladies and gentlemen, now I can add the numerators together because you're adding a whole number with a fraction. You put that over that cosine squared theta. So here's the idea. You say, wait a minute, I've seen this identity before. Go to the browser. The Pythagorean identity we just proved for you is that sine squared theta plus cosine squared theta is the value 1. I mean, I think we could make that bigger. Yeah, sine squared plus cosine squared theta is 1. So I can again replace this with 1 over cosine squared theta because that's equal to 1. We've seen that on our identity list. It's one of the Pythagorean identities. And so, ladies and gentlemen, here we go. yet again, this is 1 over cosine theta using algebra to the second power. And 1 over cosine squared, 1 over cosine theta, looking back, 1 over cosine, 1 over cosine. Hey, 1 over cosine is one of the reciprocal identities. I see that in the upper left corner. 1 over cosine is the same as, does anybody see it? I know it's, you can switch left side equals right side here. 1 over cosine. What is 1 over cosine? Left side equals right side or right side equals left side. What does that equal? What do you guys see? 1 over cosine. Anybody? Because that's the thing. You have to see that there. Yes, Mike. Thank you. Thank you, Mike. It is secant. It is secant. It is secant. Thank you, Eric. Thank you, Hector. It's secant. I can replace the 1 over cosine with what it is equivalent to. 1 over cosine is the same as secant. And yes, and you're going to get now secant squared theta, and that's again on the right-hand side. So, ladies and gentlemen, just showing you here, working with identities. This is the version that you're really, this is on the right side, right? This is what we showed. The left side equals the right side. This is the version that you want to start to get used to working with using other identities, okay? So I showed you 2 ways to do it because this is, this is found in other, there are 2 ways to do it, using what I showed you, using the circular function definition. The other way is using the identity information, and this is what this topic is about. So I have to start from first principles, definitions, to show you where some of these come from. First principles, definitions. But these are building a whole base of identities that you want to know. So some of these identities you want to know like you know your name, ladies and gentlemen. Okay, so the ones that I'm showing you here in the browser, and we're only focusing, in all honesty, we're only focusing on the top identities, the top 3, the tangent and cotangent identities, the reciprocal identities, Pythagorean identities, and then I even gave you in the past some of these. I know you say, well, what about this stuff here, even and odd functions? Well, we're just, at this point here, where you could just show or use the definition. Let me even and odd formulas. You're just using the definition here of what an even and an odd function is. So here's what I mean by that. The even and odd identities they gave you, you already know by definition sine of minus theta, we've worked with that, is minus sine theta. And that was, I even proved at the time with circular functions by definition. We know cosine of minus theta is cosine theta. Tangent of minus theta is actually minus tangent theta. So we know by definition, I've actually proved all of these here for you guys. Okay? This is even, it was done by circular functions, a circular function argument when we talked about even and odd. And this meant sine was odd. This means cosine is even. This means tangent is odd. So we've looked at those by definition. You might say, but they're telling me that secant now, if I go to one of them, let's do secant of minus theta is secant theta now. Okay. And I guess I want to color it, I like to do my facts. Secant minus theta is secant theta. Okay? Let me show you the trig proof identity version of showing that this is from the definitions we already work with. Let me show you how you do this by proof of trig. Okay, so by chapter 7, this is chapter 7, left-hand side equals right-hand side. So you start with the left-hand side. You say the left-hand side equals secant of minus theta. Now, typically you start with what's called the more complicated side. And this is how we start with this. Secant is secant of minus theta is on the left side. So we start here. So we focus on this. And we start to think, okay, what do we know about this? Right? This is on the left. What do we know about secant minus theta? Oh, I know that secant is the reciprocal of cosine. So this is 1 over cosine of minus theta here. Okay? Secant minus theta, 1 over cosine minus theta. You say, why? Because I'm using the identity list here, ladies and gentlemen. I'm using this identity list. So I'm proving this by using identities, which is really the name of the section in the section, if you guys want to know. They should call it proving by using identities. And then you go, oh, well, I know about cosine. So I'm focusing on this cosine minus theta. That's the same as cosine theta because cosine is an even function. So you're focusing on this. Cosine's even. So if you want to notate that, you can notate that. Cosine's an even function. And then again, by my definition or by my identity of 1 over cosine, it's on the list because I know my identity list. 1 over cosine, and you go, oh, but Mr. Judge, I don't have a 1 over cosine. Oh, yeah, I do. It's there. 1 over cosine is going to be what? Secant theta. Yeah, there we go. So I can replace this now with secant theta because that's what 1 over cosine is. I see this on my identity list. So you're not doing anything without knowing these identities, ladies and gentlemen. And that's going to be on your what? Right-hand side, secant theta. It's going to be on your right-hand side. And there it is, ladies and gentlemen. Secant theta, that's on the right-hand side. So you showed that the left-hand side is equal to the right-hand side. And this is actually starting to prove working with identities. Yeah. So some of those identities on that list, these even and odd, are also there. Similarly, so if you've done, if you've done one, you could do the others on that list. But this is kind of what I'm saying is you're starting to see how to work with these identities. And so if I look at your book here, let me share something with you guys looking at the book. On page 7.1, this is the idea behind identities. You have fundamental trig identities are telling you, and this is section 7.1, page 528. So this identity sheet partially is on in your text. Page 528, and it's section 7.1. And this is the idea, this is the stuff that we've gone through to let you guys know. But if you want to have the guidelines now, and that's page 530. Okay, so I'm going to write down some of the guidelines. Here's the first guideline. They say start with one side. So you're always going to start with one side. Okay, and then I'm going to say pick one side of the equation and write it down. Start with one side, and your goal is to transform that side into the other side, like we've been doing. They say it's usually easier to start with the more complicated side. And here's the second guideline. They say, use known identities. That's what we were doing. Using the known identities from that identity sheet. Okay? And so here's what they're going to say. Use algebra and the identities you know to change the side you started with. So remember the whole idea. You want to use known identities, algebra, really arithmetic, same thing, logic, you know. Use known identities, algebra, arithmetic, and logic to accomplish that task, really. And step 3, if you have to, convert to sines and cosines. Because that's kind of the fundamentals. You do that if you get stuck. Okay, so you do that if you get stuck. So this is kind of everything that I started to talk about with you guys in my note, but you know, just want to coordinate this with the textbook that you guys have. These are the guidelines on page 530, section 7.1. So let me give you guys an example here. Tangent theta over secant theta equals sine theta. Now, your text says to verify this. I don't think that's a good word. I'm going to do what you're really doing. You are proving these identities. You're proving this. Okay, so we're going to take a look. This is the book's guideline. I have a left-hand side equal a right-hand side. So this is the book's guideline. All right. So tell me if you guys agree. This is on the left-hand side. On the left-hand side, this is where I start. We say that that's equal to tangent theta over secant theta. That's on my left. That's where I start, tangent theta. And I'm going to suggest, isn't that more complicated? Isn't that the more complicated side? I would say so. It's more complicated because it has a quotient. And on the other side, The right-hand side just happens to be a single trig function. So this is what they're saying here in the guideline. They're saying for you to start with one side. The goal is to transform that side into the other side. So we started to the left side. We have to transform the left to the right. So this is why we write this down. We write down the left-hand side is what this is. It's tangent theta over secant theta. We're trying to show, here's what we want to show. We want to show that this is equal to the right-hand side. That's what they're telling us. And what can we do? We can use known identities. Well, that's what I told you. We could use algebra. Well, that's what we've been doing. Arithmetic and logic. Replace, substitute. These are all the things that we started to work on this morning. And again, if this gets too complicated, if you get stuck, they're telling you, hey, convert everything to sines and cosines. So this is your book's guidelines, which is exactly what I've been saying to you to do. So ladies and gentlemen, there you go. So here's how we have to work with this. We have to work with things that we know. Now, let me tell you guys what we know. On the identity sheet that I put there for you guys and on the page in our book, look at the browser. On that sheet, we're using the upper left corner. There's not a lot to use. So I would say to you, tangent theta is sine theta divided by cosine theta. Okay? And that's tangent theta. So if I start to do some different coloring scheme, if I said, hey, tangent theta, sine over cosine, that's all we did. Secant theta, 1 over cosine theta. So I'm using the identities, ladies and gentlemen, on the identity sheet. So if you don't know your identities, I'm gonna highly recommend you study and you memorize these identities. You know them like you know your name. Because if you think on a test, all you have to do is look back at your identity sheet without ever studying them or knowing them, it's not going to work out. It just doesn't work that way. If it's just looking at a sheet, it ain't going to happen. So you do want to, write this stuff down like I just did. That the only way you really know how to do this is if you write this down. Then you now say, okay, well, what does this do for me? Well, take a look at what this really means here. You have to understand you're looking at a complex fraction. Sine theta over cosine theta divided by 1 over cosine theta. This is a complex fraction. This was the green portion we just did. And then this was the orange portion we just did. Okay? And so now, ladies and gentlemen, I know how to divide two fractions. And I do every step personally, because I don't want to make a mistake. Okay? This is division. This is a vertical definition of division. And we now did this horizontally. So notice what I did. Okay? I still have my fraction. I still have my second fraction. I just wrote my division question, ladies and gentlemen, horizontally, left to right. That's all I did. And then I remember, how do I divide fractions? I multiply by the reciprocal. And sure enough, doing the arithmetic, this equals sine theta over 1, and anything over 1 is itself. And sure enough, ladies and gentlemen, this equals sine theta. And then sure enough again, this is really equal to what's on the left-hand side. So take a look at what we just did. we showed here by starting, this is where you start on the left side. We started on the left side. What we showed here, and I'll put that in red. We showed the left-hand side equals the right-hand side. And this is the format that you guys want to use in starting to prove and work with your identities. This is the essence of this section, everything you've done. Now, the kind of algebra that we did here, this is the algebra portion, right? The kind of algebra you did was working with dividing complex fractions. You know, this is the algebra. So this is your first question, ladies and gentlemen. Tangent theta over secant theta is the same as sine theta. Pretty nice, pretty nice, pretty nice. So this is another example here. Let's go over another example. Cotangent theta, secant theta, over cosecant theta. This is 1. Now remember, we start with the more complicated side, and there probably won't be any debate. The left-hand side, this is on the left, is certainly more complicated than the right side. And you say, why is that left-hand side more complicated? Because what's on the right side is just the number 1. That's on the right-hand side. So I'm starting with the more complicated side. Okay. I have to show that the left-hand side, which is cotangent theta, secant theta, over cosecant theta, is equal to 1? And the answer is yes. We have to show this. All right. Now, this looks pretty complicated. I don't know what to do. I'm going to use, ladies and gentlemen, cotangent theta, the identity. Cotangent theta is cosine over sine theta. Now, this is times secant theta. And secant theta is 1 over cosine theta. Cosecant theta is 1 over sine theta. So if I really had a color coordinate, cotangent is right in here. Secant is right in here. And I don't know what color to use now. Okay. Cosecant theta is right in here. So double check I have the right identities. And then guess what goes away? My cosines cancel. So I'm now left with 1 over sine theta over 1 over sine theta. And guess what happens now, ladies and gentlemen? Anything divided by itself, 1 over sine theta divided by 1 over sine theta, anything divided by itself is always 1. So, ladies and gentlemen, this equals 1, which happens to be on your right-hand side. So I showed the left-hand side equals that right-hand side, okay? And there it is. And you are done with this question. Okay, this is the start of chapter 7.1. So you guys know. And I'll go to the assignment portion now. And I'm going to start to give you guys some homework on 7.1. Now, again, I'm going to go back and do some applications for law of sines and law of cosines. But what I want to do is create a kind of worksheet for that. that already has like some pictures for you guys, so I can save time on pictures. But we're going to get started on this section. So I'm going to do, this is a pretty big section. Okay. These are going to be the odds. So for homework, you guys want to do like 7.1, 1 to 71 odd. You're going to get started on those things. We're going to do more of these tomorrow. We're going to work with these identities here tomorrow. But I want you guys to get started on that. And it's a pretty big deal. And I recommend you guys get started. And ladies and gentlemen, I hope you guys enjoyed the lecture because we're out of time. And we want you to print your name here for attendance purposes. And you guys have a great day. Stay safe. Get started on this homework on a nice, cool October day. All right. See you guys later. You've been great. Have a great day and take care.